Welcome to this session. In this session, we shall be discussing about the composite pattern. Now, let us get started. Many times, while solving an application, we find that there are groups of objects which contain other primitive objects and groups of objects. It is a very common problem. Just to give an example, that you might be having a drawing package. In the drawing package, you may draw lines, you may draw circles, rectangles, and then you may select this and make this into a group. And then you can deal with the group just like a primitive element. For example, you might copy the group and the group will appear here. You might draw few more primitive objects and then again you may form a group which contains two groups and a primitive object, and then move it. That will be just like a primitive object is moved. You can move a group, you can reduce the size or expand the size, you can copy it, and so on. This is a very common problem. We will see that in many places it occurs. Basically, if you look at here, a group contains some leaf elements and also can contain a group, and this group in turn contains another group here and another leaf here, and this group contains only primitive elements. In the drawing example, we first draw the primitive element, form one group and then add more primitive elements and then form a larger group and then add more elements, or we might repeat this group here and all these will appear here, and then we form still a bigger group and so on. This is a very common problem in many applications. So, here an object may represent a group or it may represent a leaf level item or an individual item, but then they must behave similarly. How do we structure the classes here? That is the main problem. It is a structural pattern where we are interested in determining how the different classes participating in the group, some of them are primitive, some of them are composite, how will they be structured. So, that is the main problem that we are trying to address here. Another example is a computer aided design package. You can draw a very sophisticated design here, a layout of a VLSI, and then here you form many groups and the groups are repeated, changed and so on, and it makes it easy to draw just because you are using the notion of nesting objects, forming groups and so on. There are other examples. This is a mechanical CAD, mechanical computer aided design editor. You can build complex diagrams using simple components. For example, you select the side A, side B and bridge, and then this becomes a group. Now, you can have you can copy it and paste it, add more primitive elements, form larger groups and so on. So, here just using the drawing package, we selected copy, paste here, we got the same one here, the group is pasted, we can resize and so on. The group we pasted here, resized the group and still we can make a larger group and so on. So, we again pasted the group, we resized and then we copied it and again pasted. So, these are some of the common things that are done in a editor. Now, our focus here is that how do we use the composite pattern, what is a good solution for this problem. The intent of the composite pattern is to compose a nested group of objects into a tree structure. A nested group of objects into a tree structure that represent part-whole hierarchies. Group consists of some primitive elements and another group here consists of primitive element and another group. The top level group here contains 3 primitive elements and a large group. And one thing we must keep in mind that in these applications, the user must not be able to do different things when dealing with a group or a simple element. A primitive element, he can copy, paste, he can move, he can resize and so on, and the same thing he must be able to do using similar operations on a composite item. So, that is the requirement here. Now, first let us see that if you do not use the composite pattern, what would happen? If you do not use the composite pattern, one is that the user or the client might have to treat the primitive and the composite differently. For example, if it is a primitive element, he might just move it. If it is a composite, he might have to repeat the move operation across all the elements and so on. That will be not a very elegant or acceptable solution. The application would become complex, and if we add new types of primitive elements and new groups, it would become extremely complicated, troublesome for the user. And as you can see that the composite pattern solves a very important problem, and in the right situation you would have no difficulty in identifying the right situation and using the composite pattern, which will really help in making your application elegant. Now, let us see if we pose this problem to a novice programmer, that see we have this group of elements, we should be able to form group of elements using primitive elements, and then we can form larger groups containing groups and primitive elements and so on, and the group and the primitive element must behave similarly with respect to copy, paste, resize, move, delete and so on. Now, how will a programmer approach this problem? Let us see that the mistakes that he will do, so that it will become clear to us that the elegance of the composite pattern. If we pose this problem to a novice, the first thing that will strike to his mind is that there is a nested group of objects, and how does he do the nesting? So, he might, so this is the nested group of objects, and he will try to address this problem, and a typical designer who does not know the composite pattern, he will come up with this kind of solution. A composite contains leaves, many leaves, and then the composite, the method supported is for all, and here for the leaf it is operation. And if you want to, let us say, move a composite, it will invoke the for all, and the operation, specific operation may be move. I have just written here operation, the operation may be move, may be delete, may be resize, etc. So, the composite, the client would have to call for all, and then that will in turn call the corresponding operation on the leaf. But if the client deals with a primitive object, he would have to call the operation directly. Now, let us see what are the difficulties with this solution. As you can imagine, the first difficulty is that the client has to treat the composite and the leaf separately. He has to invoke for all on the composite, and on the leaf he has to directly call the operation. And another thing to notice here is that this is a single level of hierarchy. What we really needed was a nested tree. And also the composite contains one type of leaf. We wanted it to contain many other composites and leaves. Definitely not a very good solution. It falls way short of what is required. It is a very naive solution. The problems are that only a single level of nesting, the composite and leaves are treated differently, difficult to extend. For example, how do we add new composites, new leaves, and so on? Not a good solution. And if somebody is posed this problem as an examination question and he gives this answer, then the examiner would possibly award him 1 out of 100, not a good solution. You can see here the client has to distinguish between whether he is dealing with a composite or a primitive operation. If it is a composite, then it has to call the for all, otherwise he has to call the operation directly. Getting a complex group out of this is very difficult. Nesting is not supported, different types of primitives, different composites, it is very hard to support, not a good solution. Now, let us say we ask the designer to go back to the design table and to come up with a better solution. In the second attempt, he tries to address the problem that there was no hierarchy, there was only a single level of hierarchy. He might come up with this, that an item contains many children and the item can have further children and so on. You can see that there is a multiple levels here possible, and here in the item can be a composite or it can be a primitive element, and if it is a composite, if there are children, then for all children do the operation, else do something. Again, not a very elegant solution, because how do we support new types of primitive elements, new types of composites, and also this if then else does not look okay. Definitely there are improvements over the previous attempt. The previous attempt was restricted to a single level of hierarchy, and here we are having multiple levels and also kind of unified treatment for the composite and the primitive element. The client does not have to really distinguish between the composite and the primitive element. He just makes a method call an operation, and then the operation internally checks whether there are children, then do the operation for all the children, otherwise do something. But then what are the problems? The problems are that does not handle different item types, different primitives and different types of composites. Difficult to extend. Now, we have to ask the designer to go back to the design table and come up with a better solution, but if we as examiner we have to give a mark to this, the extent to which it satisfies the requirement of the original problem, we might give 40 out of 100. Now, the attempt 3, the designer comes up with this design, extended basically the previous solution. There is a hierarchy here, the item, and then there are different types of items supported here through a inheritance relationship. The item can be item 1, item 2 and so on. Again, this is not a good solution, definitely improvement over the previous one, because different types of item can be supported, different types of primitive and composite items can be supported. But then one is that item is a concrete class, and then these are all concrete classes, and then we will have difficulty with respect to the Liskov substitution principle, and also to group items into multiple primitive elements and composite elements does not look very correct. We have been able to add new type of elements, that is the improvement, and if we have to give the mark, we will say that it is 50 out of 100. So, this is the third attempt on the designer. Now, we ask the designer to go back to the design table and come up with a better solution. Now, he comes up with this solution that an item is abstract here, does not violate the basic principles, object oriented principles like the Liskov substitution principle, and then the derived classes are either primitive elements or a composite. There can be different composites, of course, and then the composites contain the items which can in turn be primitive items or may be composites themselves, and this is the solution that we required, and this exactly is called as the composite pattern. Here an item can contain many primitive items, or it can contain some primitive items and some composites and so on. So, this is the solution that we required, and this is called as the composite pattern. As you can see, if you do not know this solution, you will have to really struggle to come up with this solution, and that is why it is good to learn this composite pattern well and apply it wherever required to come up with elegant object oriented programs. Now, this is the pattern, I just rerun that. There can be multiple leaves and multiple composites. A just simplified representation of the composite design pattern. The composite contains many children, and each children can be a leaf object or a composite object. And the problem the composite pattern addresses, as you have already said, that how to organize a hierarchical object structure so that the clients are not required to be aware of the hierarchy. They deal with large composites, small composites, primitive objects exactly in the same way. And for all, as you can see, that they just invoke the specific operation without having to know whether it is a large composite, small composite or a leaf. Now, let us look at the issues here. We must, to be able to understand and apply the composite pattern, we must know the class diagram, which I have already seen. We must know how the client interacts with the composite objects and the primitive objects. What are the operations that are defined for the component, the composite and the leaf, how are they carried out, and how is the design implemented, that is what will be the Java code look like for a given class structure. Now, let us address those issues. The first is class diagram. This is a very elegant solution, and if we say that composite pattern, this must come immediately to the mind, that there is abstract component and then there are primitive leaf elements and then there are composites. A composite contains many components and each component can be a leaf or a composite. The client invokes the operation on the component, and the component may be either a leaf or a composite, and the operation is defined here, is abstract class and if necessary overridden here. Now, let us look at how the client interacts with the composite pattern. The client manipulates the composite through the component interface. Component is the abstract class, and the different methods that are defined on the component, it manipulates the different objects. The object can be either a primitive object or a composite object. So, these are the operations. The operation add, remove, and the client invokes these without knowing whether he is dealing with a simple primitive object, a small group or a very large group. The same operations are supported by all. So, this is typically happens in a CAD drawing. There are many other applications, as you will see just now. Here please remember that the component is an abstract class. It declares the interface which will be usable by the client. It defines some behavior that are common to the leaf and composite, and the composite may define more methods. We will see these methods. Now, the leaf has no children, and it just defines the operation that is defined in the component. The composite, in addition to the operation defined on the component, must have operation for child management, for example, add child, delete child and so on. So, the composite defines behavior for the components children, store or add child component and other child related operations, invoke different operations on the child, delete, etc. Now, the client interact using the component interface, and the component may be a leaf or a composite. If the recipient of the client method invocation is a leaf object, then it directly handles the query. If it is a composite, then it just invokes the corresponding operations on the children objects. And this is the object diagram. Different objects here, there are composite objects which contain other objects and primitive objects. So, it will be not very difficult for you to draw the object diagram given a code or a running of a code. In this pattern, it becomes possible to define recursive composition of the primitive and composite objects. That was what was required to form the groups. On the client side, the client invocation is very simple, does not have to distinguish between the composites and the primitives. From the programming point of view, one can easily add new kinds of primitives and composites. This pattern is applicable wherever there is a part-whole relation between objects, but then we must be able to form larger groups from dynamically using the primitive elements and other groups. So, this is very important that this is applicable when there are part-whole hierarchies, but then we must be careful that we must have the problem that involves creating composites using primitives and other composites dynamically at the runtime. We will see some examples where we will again highlight this point. This is what is important, not only the part-whole hierarchies exist, but also the parts, the composites should be created dynamically at runtime. We should be able to identify some elements and then form that into larger groups, and then still form larger, more bigger groups and so on. We can copy a group multiple times and make that into a larger group with more primitives and so on. We will take some examples and look at the kind of code that will correspond to this design pattern, but we are almost at the end of this lecture. We will stop here and continue in the next lecture. Thank you.